thought I'd do a little bit for some AI, because why not? Who doesn't like a good AI? So I think just to start off with real quick, so I'm gonna start it with just a 3D object. We'll even use just a cube, and we can always do animations and all that after. Actually, you know what? I am going to use an empty object. I'll put the cube as a child to it. Right? Like if you had a like a graphics thing. So this is your actual AI. Now, that structure could change too, depending on what form of movement you're using. First of all, we're going to need an agent. Let's go down and make sure that's set up. So the model for how it sits, probably have to move that up. Yeah. Let's bring him down. I guess it's really not that important right now. But anyways, so we have an agent. Now the agent can't do shit all unless we bake a nav mesh. Here, I'm just going to put a couple things here. Some walls that could be used for later on. Demonstrational purposes. I got U-model here, so I'm just using that real quick, but these could technically be anything. And I'll mark those as static. Sure, change children. And let's bake. Alright, so now our AI can at least, there's a little world that they can move around in. Walls are excessively tall, but that's okay. It doesn't matter. So I think one of the things I'll do though is I want to make sure, like it's such an easy thing to ignore, and it's kind of a bad thing to do, but you really should get in the habit of utilizing your layers. And you don't want everything on default. You don't have a lot of control if you're doing it that way. So for example, let's, like, I've already got whatever layers in here, but say we have a layer called terrain. So and these ones here can almost be on a different layer called wall or something like that too. But let's make sure that's like that, and that's going to allow us to utilize sight and stuff. So now that we're static, we have a nav mesh, we can do something with our AI. So with AI, I like to have a couple different FSMs, right? I'll typically have one called stats. You can also call it health. One called brain. Usually I'd have one also for the animator as well, which actually works fine for doing it this way when you have like a hierarchy where you can just take whatever model, put it here, and then you just say, hey, this is, when it comes to the animator, you're controlling this thing. And then that way, if you wanted to swap out your AI running different models, you literally just swap the model out. But your AI is technically on an empty or something like that. It's like a little package. Right, so the other thing we would, well, no, I think we'll do it in the brain. So, like I said, now stat-wise, you could have all kinds of things. Health, hunger, thirst, whatever. All sorts of things. We'll get into that one later on. So in the brain, we would want some sort of sight system. So I'm going to make a new FSM because I'm going to just template it. And in this FSM, we got to define what is sight. Okay, so if we had a player and this is our player, and they'll be on player layer, which is important. Now we could, and it's kind of a nice thing to do, is to also have a object we'll call it sphere, and this could be on a sight layer. And if that's the case, and the main reason why you'd want to do this is normally if you had a player or any other model, the anchor point's at the bottom. So anytime you do a calculation for sight and stuff, or if you want to check for distances and stuff, you're always looking at the anchor point, which is typically right at the bottom. When it comes to sight, if you're going to do Raycast, that's not a good method, because if you run a Raycast right at the bottom of this map, if there's like a rock here, they're not going to see it. So if you build objects such as this, maybe mark this as a trigger, and it's on its own layer, we can now use an eye target from here and fire at objects like this to determine if we actually see it. And it's a little more dependable. So with that said, you might want to have a category in here. You know, like this could be, you know, eyes, and you could put this right into the roots, like in the bones if you have a model. For now, I'm not going to worry about that too much. I'm going to put it up here. So sight, what is sight? So for me, it's about the overlap. It's all about the overlap. So if we do a get overlap sphere even, and we can do it from this target, and we'd have a radius. Use a variable called sight range, and we could use our sight layer, and this would give us an array. So let's give an array potential, whatever, sight objects. So we would have this cast a big sphere and find everything that has one of these sight objects. Right, but that doesn't necessarily mean we have seen it. Right, because if we have found it, we need to see if we can actually see it, or if it's behind a wall. So the other thing is, what if it's behind us? Right, so the first thing I would want to do is we have cast a overlap. Now we're checking on this sight layer. We can now add a tag filter, right? Such as, okay. Well, first let's do it this way. Let's do an angle filter first. So let's get position, or no, I guess we actually have to go through the array, or else we're not getting the position of anything. So if we're going to loop through the array, because we have seen at least one object, right? So we're going to loop through our filter angle, or our angle filter. So this is going to be our current object, right? So we have current object. So we loop through, and what do we need to do? I'm going to grab our position here because we don't need to do it every freaking time we loop through. So let's get position. Actually, you know what? I think there's an action called get angle to target. That might be easier. That might be easier. Ignore height. Yes. All right. So that's the angle. Yeah. Okay. So then we don't have to worry about this little section here. I was going to do it the old school way, but if this works, then this works. So we're going to get the angle to the target from this array. And the first thing we want to do is compare. Because if this angle is less than a sight angle, okay, so we have sight angle, let's make that an input, and sight range is an input because that can change based on AI. So if it's less or equal, it's going to get a pass. Pass. If it's greater, it's a fail. And if it fails, we're going to go back to the array and check the next object. So what this is more or less stating now is if our AI is here and he's facing this direction and we are here, our angle to the AI would be like a 1 degree right now. So that would be a pass. Our AI would be looking at our player. If our player is over here, we're at like almost a 90-degree angle, right? And if we're back here, we're at a 180. So what we're saying is at what angle can our AI see at? That's what that angle is. So we overlap, collect everything. Okay, now we've got everything. Are they within right angle? Because if they're not within the proper angle, then screw it. We'll just, there's no point in testing anything else because we can't see them. All right, so we're looping through, and it's a fail, so we go back. But if it's a pass, then we need to go down to another filter. And that is going to be where we have a eyes object. And now we're going to Raycast. I'm going to use Raycast 2 because it works better, I find it. And we're going to raycast from the eyes, and we need to raycast towards our target. So we need a direction. So we need to calculate that direction first. So we're going to get position. And actually, you know what? See, I was going to do this in the beginning, and I should have just done it. Because there's no point in getting our position every single loop. So this is going to be our current position. So we're going to grab that, and then we can go through this. So anyways, so if it's a pass, we're going to come down to this, and this is going to be our obstacle. I think there's a B in there. Maybe not. So we need to get the position of this same object that we're testing on. So this is target's position. And now that we have that, we can do a vector3 operator. A vector3 operator, all we're going to do is take target position and our position, and we are going to subtract them. And now we're going to end up getting a direction, and that is what we need for the raycast. So we're going to raycast from our eye object the direction of direction space world. This distance might as well only be the sight range. And now we're going to see hit or no hit. Now we should get a hit, right? I mean, if we're doing the same direction, same range as the overlap sphere, so we're obviously going to hit something, right? But we're going to put the no hit in as like a fail safe. I mean, it shouldn't happen, but we're going to put it there anyways. But anyways, so we've hit. The odds are we're going to hit something. Don't know what we hit, but we're going to hit something. So we hit something. There we go. We've hit something. So what we need to do is we need to store the hit object. What did we hit? And I'm going to run a layer mask. And I want the sight layer, and I want the ground layer, terrain. I want our terrain layer, right? Because our terrain is our obstacles. You could have 3 or 4 different layers for that, right? Because you might have another layer of props or something. But anyways, I'm not going to have that. I only have the 2 layers. I have the layer of our what could be blocking it and the player. So with that, we're going to get an object. We're either going to hit an obstacle or we're going to be hitting the player. Pretty much that's how that's going to happen. So what do we need to do? We're going to compare the game objects. We're going to compare the current object, the one that we're doing our array from originally, this object. We're going to compare it to what we just hit with the ray. And if they're equal, it gets a pass. If it's not equal, it gets a fail. Right? So fail goes back to the original loop. Pass, we can go on and do something else. Right? So now, let's group those together. This guy's kind of more of a prep. Let's group those together. Right, so we have our angle filter. And then this is also our array. I mean, technically this is our angle filter. Now let's call him angle filter. Let's call him the array root. All right, there. So we have prep, array root. Now we're going to run through our filters. So we have our angle filter, then we have our obstacle filter. No, I call this one obstacle test. Maybe we'll just call this filter, so we're in the same kind of system here. And now this one has 3 states. The other thing we could test would be, say, tags. Is this thing on the same team as us or not? Right? If it's an animal, you could also have almost like kind of like a fear factor, right? Like if you had a squirrel, you kind of give them like a power rating or something of like 1, and if it's a bear, you give them like a 10. So then you would say, okay, if the object has a lower power rating, I'm going to attack it. If it's got a higher power rating, I'm probably going to run away. But anyways, so for now, I think that's probably pretty good. So if we've passed, we're going to set a game object, and this is our scene target. Actually, I don't know if we want to do that yet, because we could still run through the array. So we could have a list of objects, right? Because we could also be testing if this object's dead or not as well. But for now, I think we'll leave it like that. So let's just set game object, and we want the game object, the scene target, as an output. So we're going to use the scene target is going to be our current object, and then we can, for example, finish FSM, because this is going to be a template, right? So if we hit here to the point we hit done, what would we want to do? We would want to wait, and we could even make this a variable. So we don't need to be doing this every frame. And then when we're done that, we'll just finish and go back up and just keep looping through. Right, so there we have a few variables now, and we can save this. Save template. So we'll call this AI site system. And I am now just going to go and delete him. So we're going to go to our brain. Now we have a site system, so let's test that. Let's just say run FSM, and we're going to run our AI site system. So we need to know where the eyes are. That's our eyes. Site angle, maybe we'll go with, say, 90. The range, maybe we'll go 10. Update cycle, maybe every half a second. So this is going to be our scene target. We'll call them, doesn't have to be the same name, but, and we'll use the finished event. So now if I take my player and I go hide over here and we hit play, we should have, oh, let's come out of that mode. Our AI is going to be sitting here, and this thing's going to be running over and over and over again, right? Like if I go into it, of course it's not doing that because we don't have that. Because it's doing an overlap sphere, and it's on found object. I don't know if that runs every frame or not. Let's test that real quick. I don't think it does. Oh, no, I didn't think so. I did not think so. So, what are we going to do? We're going to copy and paste, and we'll just loop it down here. Actually, no, let's not do that one. Let's do a next frame. I like next frames for those. I think. There we go. All right, so now Alright, so now he's cycling through, or he should be, right? If we go into there, yeah, now he's pumping that sight through. And if I come over here, we should see where he now is filtering through all this stuff. Right, and he is failing on this portion. Right, so he has the direction. I might have put that backwards. Let's do this. Oh no, he's firing. No, it's totally hitting. Did I change this thing? Nope, that's the sight layer. Here's the sight layer. Always firing above it. Okay, we have a little bit of a directional issue there. That is all. And that's an easy fix. So what we're going to do is we are going to, because we're getting the position of the sight object and we're getting the position of our self. We don't want to do that. We want to get position of our eyes, because that's ultimately where we're going to be firing the ray from. Right, so I'm firing the ray from one point, but I'm doing the math from another point. Doesn't make a whole lot of sense now, does it? So now obviously that range isn't very far. I should up that range a fair bit. Right, so there he goes. He's fired the ray. It went off. It did the whole thing. In the end, we have seen the sphere. So let's modify that just a tiny touch. So instead of setting it, let's get the root. Get the root of the current object and store that straight into the scene target. So it's kind of like the set game object, but instead of storing this guy, we're going to store him instead, because that's the actual thing that we are after. So, but anyways, so we have a sight system, and now we can put that in various other states because it's just a FSM. Right, now we might want to run these as variables as well, but for now I'll leave it. So what we could do now is, if we've seen him, we could set agent destination. Just a very simple something like that, right? As simple as that is now, right? And if I'm over here, I should have upped my, you know what, let's do that first. Let's go into here. Let's take this range and go 25. All right, so now if I'm over here, we're within range, or we should be, but there's a wall blocking the way. We cannot be seen, right? Which is why this part's failing, because it's seeing, okay, we have the sphere, he's within range, but we're hitting this frickin' wall. They're not even, so we failed, right? And now if I take our capsule and I move them this way, oh, we should have had an angle fail there. Right, because that should have happened. Oh, you know what? Let's double check that. And this is also a lot of times why I like to do my own angle math. So let's take this guy again. Let's go over here. So we can see the angle storing 0. And it seems to not care where I'm at. So we have an angle issue. So our little angle to target ain't fucking doing shit all. Which is fine, because that's, like I said, I mean, we have this position anyways, and we're getting, we have to calculate this direction. So what we'll do is I'm going to take so we're just going to do a little quick detour like this, and I'm more or less going to take this guy and stuff him in there, and now we'll just move that there. Now this is the right. So now we have this, because what this is giving us is our direction to our target, right? Which is what we're going to use in the Raycast, but we can also use that here, right? So if we have the angle to the target, how do we do, or if we have the direction to the target, how do we get the angle from that one direction? And very simply, we transform direction. So we're going to take we'll use our eyes, we'll keep it so everything's the same. We're going to go 1 on the Z, and that is our this is our forward direction. Okay, so now we have 2 directions. We have our forward direction, and we have whatever angle or whatever direction from the target. So now we just do float or vector 3 operator, and we plug in both those directions. We take the direction and our forward direction, and we go to angle operation. We store that as our angle float, and that's it. So now we're gonna collect this information, and we might even add on to that after, and then do this stuff. Since the angle to target wasn't doing fuck all for us. So now, if I come over here, we should see we're collecting that angle, right? So our angle is 97, which is about right, because I mean we're not quite just to the side. So if we're over here, I mean we're walking by him and he can't see us because we're behind him, right? We move ahead of him and he's seen us. He chases, right? Perfect. So we have ultimately we're going to have, we'll call this, say, an idle state. For now, anyways, we have an idle state, and that can be our start state. I don't know why I just didn't name this one differently. And let's call this something else. Let's say chase target. Right, so we're going to chase a target, and this could just be a chase system. This whole thing could be another template where we chase an attack. right? For now, we're just going to mark it like that. Very simple. Now, in the idle, the other thing we could be doing, though, is we could build a wander system. So let's build another FSM, and let's just do a very simple get position, and that's going to be our current position. And then we are going to random float. We need 2 of those. So we're going to need a you know what? Let's do this way. Let's go wander distance and mark that as an input. So then what we could do is this guy's going to be an X and this guy's going to end up being a Z. So the max would be wander distance on both of those, but the min can't be wander distance, because if you do the wander distance of 20, now you're doing a random float between 20 and 20, which doesn't fucking make any sense. So we're going to do a float operator at the very start of this. Move that to the top. And we're going to take wander distance, multiply that by -1, and get min distance. And now we can do min distance. There we go. So we now have a bunch of numbers. We need to set vector 3 XYZ at the very bottom. This is going to be, we'll call it our offset, and we're going to add our X and our Z to it. And now we are going to vector 3 add, move to the bottom. So we're going to take our current position, add our offset. Now we're not going to wander to that offset, because that offset could be in a bad spot. And by that I mean not on the nav mesh, right? Because if you got to imagine, if your AI is sitting here and he selects a point that's over here, you have some issues, right? So the way we're going to resolve that is go nav mesh sample position and move him right to the bottom. So we're going to take our current position, which has the offset added to it, and I'm going to use the wander distance for a max distance, and nearest point found is going to be our wander position. Let's retry. Put in our little fail safe. Give it a frame just to chill out. So that's just more or less if we do the sample position and something does fail, even with trying to find the mask and all that fun stuff, if everything fails, we're just going to repeat the process until it doesn't fail. Simple. Oh, nearest point found. I made the wrong variable there. Let's change him to a vector 3, not a bool, because he's here. Right, so we have our wander position. So what do? Let's use this event. Go wander, go do stuff. So let's set agent destination to the wander position, Now, and I've got the every frame on mine. You probably don't have that. I modified mine. Don't worry about it. You don't need it. But if you're wondering why mine has it and yours probably doesn't, don't worry about it. So, once that happens, what am I going to do? You know what? I am going to wait a frame. I want to make sure that's said and done. He's moving. Life is good. Right? Move to target. And let's get target. This one could just be called retry. So this one here, all we're going to do now is we're going to get distance. And you could use the remaining distances. I always seem to have frickin' issues with those. And there is a get distance to, which is on the ecosystem, because get distance itself can only do a distance to a game object. Get distance to does a can do a vector. So I can say from us, use owner, to the world, or to the wander position. This is our distance. Float compare. So if distance is less than, we need a value in here. Now, one thing to keep in mind is your agent might have a stopping distance, and if that's the case, then they're not going to go to the 0. Like this might be like a 1.5 kind of idea. So the lowest they're probably going to go would be like a 1.4 if they kind of slide in there a bit. So you don't want to do that. And if you have that, it becomes very easy to forget about that when you're trying to set this thing up, right? So one thing that you might want to do is get agent stopping distance. So this is our default stopping distance, and then I'm going to float add. I don't want to use that exact number because that's going to potentially cause us issues because it may not hit it. And I'm just going to add like 0.3 to it, roughly. It can be 0.2. You might even get away with the 0.1. But I'm just going to add a little bit to the stopping distance. So if our distance is less than that default stopping distance, which is now modified because of this, then we can do something else, right? So if we're equal, let's do stuff. If it's less, we can also do stuff, and this needs to be marked every frame. So if we're going to do stuff, what do we want to do? Well, let's do a bool test. So options are good. Does weights. You're probably wondering what the hell is it does weights. Well, that's going to be an input, and it's just going to be a bool that we can set for our AI. And it's just going to be so that if you watch this particular AI to possibly do weights as he wanders, then you just say yes, mark it as true. If you don't want it, you just mark it as false, and then he won't do it. Plain and simple. It's just an option to have, right? Okay, so if it's false, then we're just going to go back up here and get a new position, and off we go. If it's true, let's make another variable, which can be a float, and that could be our wait time. That could also be a random wait time if you wanted to. In fact, yeah, you know what? Let's do max wait time. Mark that as an input. and min wait time, and mark that as an input. So then now we can do random wait, and we'll just mark that in as our min wait time, max wait time, and when we're done, go to our finish. Go up there. And then you could also have that. We could put other stuff that play certain animations, play sounds. We can do all sorts of little stuff in here. Yeah. I'm just gonna leave it like that for now, though. All right. So that's everything. So we're gonna save that, and that's our AI wandering. And no, and get rid of this one. Don't need it anymore. So in our idle state, we're going to run FSM, and that's going to be AI wander. Can also make a patrol one. So this is where we can, like, hey, do we want our AI to wait? How long do we want them to wait for? This doesn't need to be anything. Distance, maybe a 10. Let's turn waiting on so we can test that and go 1 and 3. Oh, let's go a little more. Let's go 4. All right, so there we go. So if I hit play, of course I stuck him way up there. He's just doing these little, we only gave him a distance of 10, so it's not like he's got a long ways. He's just kind of hanging out and doing his thing, wandering around, right? Exactly what he's expected to do. All right, so let's move him over there. We don't need him over that stuff's in the stupid corner. I mean, a good test though. I mean, because it's a good thing to have. Wander distance, let's take this up to 3 and 7. And this wander distance, you could also make that a random value too. Like you can go in between. Oh wait, no, it is a random value. Never mind. Don't mind me, I'm crazy. All right, so now we have Joe below here. He's hanging out. He's doing a nice big long wait. He's going to go wander over there. And if I take my player now, I could sneak up behind him, do all sorts of stuff. But if I come over here now, he's doing that. He comes out of the wander and he's doing the chase. Right. So there's all sorts of things there that can happen. We can change speeds, play different effects. He doesn't even need to go to a chase. We can go to like an alert state, do some stuff, and then go into a chase. Alright, so there is the wander and the sight feeding into the chase. Let's, you know what, to make that a little more easier to see, I'm going to add an empty here. And I'm going to add a light component and make that a spotlight. Now let's take our directional light and bring this down. And apparently I have all sorts of fun stuff happening in my lighting. So let's bring all this stuff kind of down a bit. Let's get this a little darker. Not too dark, you don't want it black. Let's put on some fog. Just because, why not, right? And alright, so let's go down to our little light here. So if that's his light, we can do some shadows, sure. Maybe this is a flashlight or something. Let's go like, actually let's make his range, I think we had 25 for the sight. Let's go with that. bring this intensity up. Why do I not see anything? Oh, I wonder if that thing can even accept shadows. Oh yeah, no, it's just, it doesn't like shadows apparently. So I grabbed some sort of weird material. I'll grab something else. Probably not some random rifle material. That's not going to help us out very much. I don't want to use default because it's ugly. Not that that's, I guess, much better. Blue floor. Okay, how about that? Alright, so alright, let's take this light back up. So roughly 25, bring the intensity down now. Oh. And we have shadows. Let's give it a little bit of a yellow tinge. All right, and that'll just allow us that to look a little better. Be able to tell which way he's facing. It's like he's a little nightman or something like that. He's got his flashlight. Right, and then we always could put more on the vision, like another filter for if the object's really close, then skip like the angle filters and stuff like that, and just do the attack or chase or sight. Right, but that's working pretty good. Right, so okay, so we have our idle. We have our chase. How long have the video's been going on? I don't want to make this video too long. It's already fucking 50 minutes. Holy crap. We haven't even done that much. Wonder if I have time to do a noise generation. Maybe not. Maybe I'll save that for another video. Right, and we can put. So now stats, the stats and these things can get in, they can go pretty far, right? Because I mean, we can put in tasks and hunger and thirst and jobs and all sorts of crazy stuff, and we can just run this similar, I guess, almost in a behavior tree style method. Now we'll probably get into as we get deeper. I use array lists a lot, so keep that in mind. Where's Playmaker? Oh, there's fucking Playmaker. This here is extremely useful, the enum creator. So if you don't have a Raymaker, because that's, if you get a Raymaker, you get the enum maker, right? Because this is a great way to have things like idle, alert, you know, chase, maybe he's working, sleeping, eating. You can do all sorts of stuff, right? Searching on, that's probably good. I mean, we'll not using it right now anyways. It's kind of more of an idea. But as the AI gets a little more complex, you'll probably see we'll start using a system with the enums to help us swap back and forth around different states, because having these little states, I mean, okay, we have a water state, but that, I mean, we could easily set up patrolling states and all sorts of stuff, right? So I think for now we'll leave it that. I mean, so far it's basic, right? We have our sight system, we're wandering and we're chasing. Nothing too crazy yet, but we've now built the foundations just on those couple things for a AI system that we can do, that we can just extend as far as we want to extend it. All right, talk to you later.